Prepare to have your mind blown. Scientists just discovered that gold refuses to melt, even when subjected to temperatures that would make the sun jealous. And this revelation is about to flip our understanding of physics on its head. When someone mentions gold, your brain probably jumps straight to glittering jewelry, precious coins, or those iconic gold bars locked away in bank vaults. But here's where it gets controversial. This shimmering metal just became the star of a groundbreaking scientific breakthrough that's causing experts worldwide to question everything they thought they knew about how matter behaves under extreme conditions. Here's the mind-bending part. We've always been taught that if you apply enough heat to any material, it will eventually surrender and transform into liquid. It's one of those fundamental rules of physics that seemed unbreakable. Well, gold just proved that rule wrong, and scientists are scrambling to rewrite the textbooks. The revolutionary experiment that changed everything. A brilliant team of international researchers decided to push gold to its absolute breaking point, using incredibly powerful, lightning-fast lasers. Their mission? To discover exactly what happens when this precious metal faces temperatures that would vaporize almost anything else on Earth. What they found will make you question everything you learned in high school chemistry. Instead of obediently melting when it hit its supposed melting point, gold did something absolutely extraordinary. It basically said, "Not today," and remained completely solid. Even more shocking, it maintained its structural integrity for a measurable period, long enough to prove that our current scientific models about matter behavior under extreme stress are fundamentally flawed. The researchers managed to blast gold with heat reaching an astounding 19,000 Kelvin. That's over 18,700 degrees Celsius for those keeping track. To put this mind-numbing temperature into perspective, imagine something hotter than the surface of our sun. Yes, you read that correctly. Gold survived temperatures that exceed what our own star generates, and it did so while maintaining its solid form for over 2 picoseconds. Now, before you roll your eyes thinking 2 picoseconds sounds insignificant, let me explain why this tiny fraction of time represents a monumental achievement. In the scientific world, a picosecond is a trillionth of a second, an almost incomprehensibly brief moment. Yet in the realm of atomic behavior and extreme physics, this duration is practically an eternity. It's record-breaking, game-changing, and absolutely mind-blowing. The science behind this incredible phenomenon. This extraordinary behavior has a name: superheating. And this is the part most people miss when trying to understand why gold acted so rebelliously. Under normal circumstances, when you gradually heat a solid material, its atoms begin dancing faster and faster until they eventually break free from their organized structure, causing the material to transition into a liquid state. It's a predictable, orderly process that follows well-established rules. However, when you bombard a material with heat so rapidly that it doesn't have time to process what's happening, something fascinating occurs. The atoms essentially get caught off guard. They don't have sufficient time to reorganize themselves into a liquid structure, so they stubbornly remain in their solid formation, even though they've technically exceeded their melting point. It's like they're frozen in confusion, maintaining their original state, despite being subjected to impossible conditions. But here's where it gets even more controversial. Scientists previously believed in something called the entropy catastrophe, a theoretical hard limit representing the maximum temperature any solid material could withstand before being forced to melt. This limit was calculated to be approximately 3 times a material's normal melting point, and it was considered an immutable law of physics. Well, gold just obliterated that theory by surviving temperatures up to 14 times beyond what should have been possible. That's not just breaking the rules, that's completely rewriting them. What this means for other materials, while this groundbreaking experiment focused specifically on gold, Researchers are already designing similar tests for other materials, and the implications are staggering. The burning questions now are, can other metals and materials also defy our current understanding of physics? Are there substances out there with virtually no fixed melting point if heated rapidly enough? Could we discover materials that are essentially melt-proof under the right conditions? If scientists can unlock answers to these questions, we're looking at a complete revolution in materials physics. This could provide us with unprecedented tools and knowledge to tackle some of humanity's most challenging technological obstacles. Why this discovery could change everything. Now, some skeptics might argue that watching scientists blast gold with lasers seems like an expensive science fair project with little practical value. But those people are missing the bigger picture entirely. This research has profound implications for multiple critical fields. Understanding cosmic catastrophes becomes significantly more accurate when we know how materials behave during asteroid impacts, which generate the kind of extreme temperatures and pressures that were previously impossible to study. This knowledge could revolutionize our understanding of how celestial bodies form and interact. Nuclear reactor technology could see dramatic improvements as engineers now have better data about how materials perform under the most demanding conditions imaginable. This could lead to safer, more efficient reactors that push the boundaries of clean energy production. Advanced material development for industries ranging from aerospace to medicine could benefit enormously from this research. Imagine creating materials that can withstand conditions previously thought impossible. Materials that could enable deeper space exploration, more efficient manufacturing processes, or even revolutionary medical devices. The future implications are staggering. This discovery forces us to confront an uncomfortable truth. There's still so much we don't understand about the fundamental building blocks of our universe. Gold, something humans have treasured for millennia as a symbol of wealth and beauty, has just revealed that it's also a key player in pushing the boundaries of modern scientific understanding. The question now becomes, what other impossible things are actually possible when we approach them from a different angle? How many other scientific laws are actually just limitations of our current understanding? And this is the part most people miss. This isn't just about gold. This discovery could be the first domino in a chain reaction that transforms how we approach material science, energy production, space exploration, and countless other fields that depend on understanding how matter behaves under extreme conditions. So here's my controversial question for you. If something as simple as heating gold can shatter our fundamental understanding of physics, what other basic assumptions about our world might be completely wrong? Are we on the verge of discovering that many of our scientific impossibilities are actually just waiting for the right conditions to be proven possible? What do you think? Does this discovery make you excited about the future of science, or does it make you uncomfortable knowing how much we still don't understand about our world? I'd love to hear your thoughts. Are you team science is amazing, or team this is slightly terrifying? Let me know in the comments whether you think this discovery will lead to revolutionary breakthroughs, or if you're skeptical about its practical applications.